Hi everyone, hope you all are doing good. Today I am back with another new topic, clock buffer versus normal buffer. It is one of the commonly asked questions for BTech and MTech freshers. If you haven't watched my previous videos on static timing analysis, you can click on this link above. Also, I'll share this link on the description box. So without any further delay, let's get started. First, we are going to look into some of the terminologies related to this topic. First is clock. A clock is a periodic signal that is used to synchronize data transfer between storage elements like flip-flops and latches. Next is rising edge or rise time. So we know that whenever the clock signal goes low to high, that edge is called as rise edge or rise time. Whenever the clock signal goes from high to low, it is called as falling edge or fall time. So usually rise time and fall time are measured between 10% and 90%, or sometimes 20% and 80% of our input signal or output signal, and these are calculated as rise time and fall time respectively. Next is pulse width. A clock period we know is divided into times, right? There are different cycles will be there. A clock period is divided into times when the clock stays at high or low state. Pulse width is the amount of time that the clock is staying at high or low. So it is basically that particular interval for which the clock signal stays at high state or low state, and it is measured in nanosecond or picosecond. Next is clock period. Clock period is the total interval or the duration between two consecutive rising or falling edge of a clock signal. That means from one rising edge plus falling edge is a complete cycle. So two consecutive rising edge means it is a difference between two consecutive rising edge. Like from one rising edge to the next rising edge, the duration between them is called as clock period. And clock period is inversely proportional to frequency, that is T equals to 1 by F. Next is duty cycle. Duty cycle is defined as the ratio of active or the high pulse width to the total clock period, and it is calculated in percentage. So if we see this waveform, we can see here that this is the rising edge, that is when it is going from low to high it is rising edge, and when it is coming from high to low it is falling edge. And in between, whenever it is going from low to high, that is whenever the rising edge is happening, it is creating high pulse width. Whenever falling edge is happening, it is creating low pulse width. So high pulse width is also known as active pulse width or on pulse width, and low pulse width is also known as off pulse width or deactive pulse width. And whenever we have equal pulse widths, like whenever high pulse width is equal to the low pulse width, then only we will get 50% duty cycle. And this total, like rising edge to the falling edge, till we go for the next rising edge, this particular cycle, this particular waveform we call as the total clock period. Now let us see the difference between normal buffer versus clock buffer. So normal buffers are basically, they are having very relaxed rise and fall time. That means these are not balanced. And whereas clock buffers are having equal or balanced rise and fall time. So why do we need balanced rise and fall time? First we need to understand that. Why do we need balanced rise and fall time? Because unbalanced rise and fall time will create skew, and that will again create further wear delay. So it will affect the circuit performance wise, it will get affected, and also again more power consumption will happen. So that's why we should go for clock buffers rather than normal buffers, because the normal buffers, when we are having this beta ratio, that is the ratio between the width of PMOS by width of NMOS, it is not adjusted here, and that's why we are not getting equal rise and fall time. And hence, since equal rise and fall time is not happening, means we are basically violating the pulse width. And if pulse width is violated, means according to the previous waveform we have seen, if pulse width are matched, then only 50% duty cycle will come, otherwise it won't come. If 50% duty cycle is not coming, means pulse width violation is happening, and then this buffer can create a lot of issue in our circuit. it can create skew, it will create a lot of like with variations later on in the circuit, in the design we'll see a lot of performance disturbances. That's why we should not use these normal buffers. We should go for clock buffers, because in clock buffers we are having this beta ratio that is adjusted in such a way that we get equal rise and fall time, and their pulse width won't get violated, and it will be staying equal in a cycle, and hence it will give us 50% duty cycle. And while adjusting this beta ratio, we see that these clock buffers are comparatively little larger than the normal buffers. Thanks for watching this video. Do like and subscribe to this channel, and don't forget to press the bell icon. Do comment down below your feedback on this video and share it as much as possible with your friends, colleagues and VLSI aspirants. Follow us on WhatsApp and Facebook channel. Link is shared at the description box. See you next time. Till then, stay tuned, stay safe and keep learning.